Badminton is the world's fastest racket sport. A match can be played by two opposing players called singles or two pairs of opposing players called doubles. Badminton is formally played indoors on a rectangular court divided by a net. The opposing players take positions on the opposite half of the court and score points by striking a shuttle with the racket so it passes over the net and lands inside the opponent's side of the court.
The shuttle will remain at rest or continue to move a constant velocity if there is no net force applied on it with the racket as per Newton's first law of motion. The shuttle is the projectile, which means it has an initial velocity and follows a curved path determined entirely by gravitational acceleration. It follows a parabolic flight trajectory, but in a real game, the shuttle will never travel in perfect projectile motion because of air resistance and drag. The initial velocity of the shuttle influences the horizontal trajectory or range. The angle at which the shuttle is hit influences the vertical trajectory. A drop shot is an attacking shot played from the backcourt. The player must hit the shuttle when it has a low velocity in order for it to land closer to the net and hit it downwards at a large angle in order for it to have a small maximum height, which makes it harder for the opponent to return the shuttle. A smash is also an attacking shot played from back or mid-court.
For every action force, there is a simultaneous reaction force that is equal in magnitude but opposite in direction according to Newton's third law. In this situation, the action force is the racket swing forward and the reaction force is the racket bouncing backward. Kinetic energy is the amount of work needed to accelerate the shuttle from rest to a stated velocity. The highest velocity of a shuttle was during the smash shot and reached 493 km per hour or 137 meters per second. Let's calculate the kinetic energy of that shuttle. Let us assume the mass of the shuttle is 0.00475 kg. Therefore, the shuttle with the velocity of 493 km per hour has 45 joules of kinetic energy. Potential energy is the energy an object possesses as a result of its position relative to the gravitational field. A shuttle at its highest point of trajectory loses its kinetic energy and gains potential energy. Let's calculate the potential energy of the shuttle with the highest velocity. The height of the shot was about the height of a net, which is 1.54 meters. Therefore, let us assume the height of the shot to be 1.80 meters. Therefore, the shuttle with a velocity of 493 km per hour has 0.083 joules of potential energy. The total mechanical energy of the shuttle is its kinetic energy plus its potential energy. Therefore, the total mechanical energy of the shuttle with the velocity of 493 km per hour is 45.083 joules.
Momentum is a quantity of motion. Momentum is directly proportional to the velocity and mass of the object. Therefore, the momentum of the shuttle can be increased by increasing its velocity or mass.
Newton's second law states that if the net force acting on an object is not zero, the object will accelerate in the direction of the net force. In this situation, a shuttle moves in the direction that the racket exerts the force on it with the same magnitude.
According to the law of conservation of energy, energy cannot be created or destroyed. In badminton, energy is transferred in many ways. Jumping to hit the shuttle and strings on the racket when it hits a shuttle creates elastic energy. The strings on the racket move back and forth, which creates transverse and longitudinal waves. The thickness of the racket string influences the pitch of the sound. A player with good technique will benefit more from strings with a higher tension because it provides more power and control over the shuttle. A shuttle can be made out of nylon or goose feathers. Goose feather shuttles have thick bristles and better flight quality.
I love you, Mr. Newton.